Okay, in last video, we introduced the introduction of hypothesis test and statistical significance. So statistical significance is the probability of getting the result we got by chance is very small. This is the PowerPoint slide that I mentioned at the end of the video. So a result is statistical significant means the result indicates something other than chance is happening, something else is happening instead of this is just happening because of some random variability. Now let's continue in this video some important terminologies in hypothesis test. So let's go back to our note. So the first concept we are going to introduce is called null hypothesis, which is our beginning claim. We usually are trying to protect our null hypothesis. That means we are trying to keep the status quo. We are saying nothing is new, nothing is happening. What you are seeing is happening by chance. Nothing is new, nothing is happening. Based on this idea, the parameter in null hypothesis is usually a specific value. That parameter is equal to a specific value. This allows us to establish sampling distribution. We will talk more about it later on about the so-called the null distribution. We will talk more about this idea later. The notation for the null hypothesis is H with a subscript 0. For example, the coffee example that we have seen last page in our motivating example, we got a sample mean equals to 58.5, but our null hypothesis is nothing is happening, nothing is new, everything is okay. We are still having 60 milligrams of caffeine on average in a cup of half cup from this brand. If we translate this into math notation, that is our H now is our mu, which is our population mean, equals to 60. Please remember to include this mu here in your null hypothesis, because here we just are talking about the hypothesis test for the mean. You will learn more about hypothesis tests for other population parameters. I've always have my previous students who just give me equals to 60 or less than 60 or greater than 60 in their alternative hypothesis, which we will talk about it shortly. And they forgot to put this mu here. Please do put this mu here, which indicates that we are trying to test on the population mean. There are 60 milligrams of caffeine on average in a cup of half cup from this brand. This null hypothesis implied that any difference that is between your sample mean and this 60, which is our hypothesized mean, It's just happening by chance. Nothing new is happening. That is another way of saying what we are seeing here is consistent with the sampling variability, which is a natural thing. So this is null hypothesis. The second idea we want to introduce is, in contrast to null hypothesis, there is alternative hypothesis. This is usually our research question. So what you, I'm sorry for the spelling. What you try to test goes to the alternative hypothesis. The thing that is new that you want to research on, that is going to our alternative hypothesis. That is another theory which indicate there is something new going on, something other than chance is happening. The notation for alternative hypothesis is H with the subscript 1 or H with the subscript A. In our coffee example, our alternative hypothesis will be there are less than 60 milligrams of caffeine on average in a cup of half cup from this brand. Remember, we got a sample mean of 58.5 milligram, right? And I suspect that the true population mean is less than 60 because I'm still very sleepy. So this is something that is new. We are told the true population mean is 60. I'm proposing a new theory. So this is a new theory, and this is something that we try to research on. So this is our alternative hypothesis. If we try to translate it into a math notation, that is HA is mu less than 60. Again, please don't forget the mu here. So our null hypothesis is always going to be with the equal sign, and what you try to research goes to the alternative hypothesis. What the question is asking you to test goes to the alternative hypothesis. The next important terminology is called test statistic. It is a numerical measurement of the sample statistic you got from the sample minus the null value, which is the value you specified in your null hypothesis. Remember, we said the null hypothesis is always with the equal sign. So that is your null hypothesized value divided by null standard error, which is standard error if your H null were true. Then it is this null distribution that I've mentioned before. So the null distribution is the distribution of the test statistic, assuming the null hypothesis is true. The test statistic is the thing that we have talked about, right? Some numeric measure you constructed to measure the distance between your sample value and what is expected under the null hypothesis. Assuming your null hypothesis is true, then the distribution of the test statistic we constructed is called null distribution. So this is what is likely if H null were true. And this null distribution is usually created by simulation or by theoretical model. We are not going to talk about how we know the null distribution is, some t distribution or normal distribution. We will just tell you what the null distribution is. But if you want to know why, that is created by simulation or by some theoretical model. Okay,